Hi, my name is Rachel. Welcome to this journey through technology. Today we are going to study the chapter, which is Blockchain Fundamentals. In this chapter, we'll explore what a blockchain is, how it works, and why it is so important. We'll learn about transactions, fees, forks, and even the challenges blockchains face. By the end, you'll understand how this invisible digital system powers cryptocurrencies, NFTs, and even banking. What is a blockchain? A blockchain is like a digital notebook that is shared with everyone in the network. Once something is written in this notebook, it cannot be erased or changed easily. This makes it very trustworthy. Each new piece of information is added in a block, and these blocks are linked together in a chain. That's why it's called a blockchain. Distributed ledger basics. A ledger is just a record book that keeps track of who owns what. In banks, this ledger is controlled by the bank itself. In blockchain, the ledger is distributed, meaning everyone in the network has a copy. This makes cheating or fraud very difficult. If one person tries to cheat, the others will see it and reject the false information. Block structure. Each block is like a container filled with data. It usually contains transactions, a timestamp, and a special code called a hash. The hash works like a fingerprint for the block. It makes the block unique. Each block also stores the hash of the block before it. This linking is what creates the chain part of blockchain. Transaction structure. A transaction is simply a record of value being sent from one account to another. For example, Alice sending 1 Bitcoin to Bob. Each transaction contains details like sender address, receiver address, and amount. Transactions also have digital signatures to prove authenticity. Only valid transactions are added into blocks. Account-based model. In the account-based model, every user has an account that stores their balance, similar to a bank account. Ethereum uses this system. When you send money, your balance goes down and the receiver's balance goes up. It is easy to understand and track. However, it can be less private because balances are openly visible on the network. UTXO model. UTXO stands for Unspent Transaction Output. Bitcoin uses this system. Instead of keeping balances, it keeps track of individual coins or outputs. Imagine you have 2 coins worth $5 each, and you pay someone $7. You give both coins and get $3 back as change. This makes transactions more private, but also a little harder to understand. Comparing account versus UTXO. The account model is simple, like a balance sheet, but less private. UTXO is more complex, like dealing with physical cash, but gives better privacy and flexibility. Different blockchains choose different systems based on their needs. Ethereum prefers accounts for smart contracts, while Bitcoin sticks with UTXO for security. Both systems have pros and cons. Transaction lifecycle. First, you create a transaction like sending money. Then, the transaction is broadcast to the network. Miners or validators check if it is valid. Once confirmed, it gets added to a block. Finally, the block becomes part of the blockchain, and the transaction is complete. This entire journey is called the transaction lifecycle. Mempool. Before transactions are added to a block, they wait in a temporary storage area called the mempool. Think of it as a waiting room. Miners or validators pick transactions from the mempool, usually choosing those that pay higher fees first. If the network is busy, transactions may stay in the mempool longer. Eventually, they are either confirmed or dropped. Gas, fees, and incentives. In blockchains like Ethereum, you must pay a small fee called gas for every transaction. This prevents spam and rewards miners or validators for their work. The fee depends on network activity. More demand means higher fees. Without incentives, no one would secure the network. Gas ensures the system keeps running fairly. EIP 1559. EIP 1559 is an improvement to Ethereum's fee system. Instead of only bidding fees, now there is a base fee that gets burned, removed from circulation, and a tip for miners. This makes fees more predictable and reduces inflation. It also helps balance supply and demand. Many consider EIP 1559 a major upgrade for Ethereum's economy. Forks. Sometimes, a blockchain can split into two versions. This is called a fork. A soft fork is a small update that remains compatible with the old system. A hard fork is a bigger change that creates a new chain, like Bitcoin Cash splitting from Bitcoin. Forks happen when the community disagrees on rules or wants upgrades. Reorgs. Reorg means reorganization. This happens when two miners create blocks at the same time, and the network must decide which chain continues. The shorter chain is abandoned, and transactions may need to be replayed. While reorgs are usually temporary, they show how consensus decides the true blockchain. Stronger consensus reduces such issues. Public blockchains. Public blockchains, like Bitcoin and Ethereum, are open to everyone. Anyone can join, send transactions, and help validate blocks. They are transparent and decentralized. However, they can be slower and more expensive because so many people are using them. Still, they are powerful because they don't rely on trust in a central authority. Permissioned blockchains. In permissioned blockchains, only selected participants can join. They are used by companies or governments that need control. For example, a bank may use a permissioned blockchain to share data only with trusted partners. They are faster and more private, but less decentralized. These blockchains trade openness for efficiency. Scalability trilemma. The scalability trilemma says that blockchains can't have all three: decentralization, security, and scalability. Usually, they must choose two. Bitcoin, for example, prefers security and decentralization, but is slower. Some newer blockchains sacrifice decentralization to become faster. Designing blockchains is always about trade-offs. Finality. Finality means how certain it is that a transaction cannot be changed or reversed. In Bitcoin, you usually wait for 6 confirmations to be safe. In Ethereum, finality is reached after a few minutes. Stronger finality means higher trust. Without finality, people might fear that transactions could vanish. Real-world blockchain ecosystems. Blockchains are not just about Bitcoin or Ethereum. There are many ecosystems like Solana, Polygon, Avalanche, and Hyperledger. Each has its own strengths: fast payments, smart contracts, or enterprise solutions. Together, they make a huge global system powering finance, art, supply chains, and even gaming. Blockchain is everywhere today. Conclusion. Today we explored blockchain fundamentals: what a blockchain is, how transactions work, and why fees, forks, and finality matter. We saw how different models like account-based and UTXO work, and how blockchains face the scalability trilemma. We also looked at real-world ecosystems making blockchain practical. This is just the beginning of our journey. Next, we'll go deeper into architecture and advanced systems. Thank you for joining me.